Now we'll take time out for a little theory discussion concerning the cone, what I call the cone point setting for the differential drive shaft. This to me is the first setting to adjust when reassembling a transmission, and in my case it's the last one that I'm going to check before taking it apart in case I need to do any adjusting if and when I need to replace the differential drive shaft bearings. I don't know their condition yet. So in the service hint from January 1944, number 2L, this procedure is explained in detail, and I've tried to reproduce the drawing here. The most important issue is that the shim pack in the rear differential drive shaft bearing needs to be set correctly, so the differential drive shaft cone of the pinion is in the correct relationship to the differential. And so the procedure says to put a 2 to 2 3/4 inch bar stock sitting in the differential bearing valley, and the point of that is something heavy that's going to sit still in there. To fabricate a steel spacer block, it says about 1 1/8 inches, and from my experience the closest you can get to 1 1/8 inches with good square surfaces the better. In my case I ended up having mine trued off, and it ended up being smaller than that. And as a result of it being smaller, the feeler gauge shim pack, or the feeler gauge that you insert in here, ends up being, in my case, too thick to have good confidence of its fit in there because it's too hard to deal with. I'll show you that in a minute. So the magic number is 1.172, or the target number is 1.172 inches in the dimension here, plus or minus the number etched on the pinion, and I'll try to show with a light later that the number on my pinion is minus 24, so negative 0.024 is the compensating number based on the machining of the pinion. And by doing the arithmetic then, you can confirm what shim pack you need in the bottom, and if the shim pack is correct in my case, then these numbers will work out. So 1.172 minus my 24 thousandths on my pinion gives me a target number of 1.148. The shim pack that I put in here, that as far as I can tell is reasonably close to being the proper fit in there, is this total here of 0.0725, and again that's too thick to really have a good feel in there because my spacer block is about 1/8 of an inch too short. And so my block measures 1.075 instead of the target 1.125 inches, and the sum of my shim pack plus my spacer block works out to 1.1475, which is pretty close to 1.148. So that's the theory of it, and now I'll show how the parts and the shim pack were done. On the end of the pinion shaft, I've found in the past that there's likely to be multiple numbers etched, but in this case I don't know if you can see, there's a 2-4 there in addition to the manufacturing numbers or codes that are on there. So on top of that we put the spacer block, and as I said, in my case it's really 1/8 of an inch too short for what I would like for results, so that sits on there. And then when I put my tube in there, I'm coming in through here and I'm measuring from that block to the tube. So I wasn't able to get a 2 to 2 3/4 inch round bar stock, but I was able to get a 2 1/8 bar stock, which fit inside here, and that keeps it steady in here. That's the point of it being bar stock, I think, is just to have some mass to it, so that with that in there sitting on the bearing, and it gives the dimension to sit on the bearing surface, and then the pinion and the spacer block are underneath. The procedure then is to go in and measure the distance from the spacer block to the bottom of the pipe, or the bar stock, around machine, or around good bar stock, and that's how I measured that. And in my case, from the wear pattern I saw, at least on the oily wear pattern on the pinion, and or the ring gear and the wear pattern on the pinion. Uh, from what I see from the oil or wear pattern, I don't expect I'm going to change anything here. And now the next step is going to be to remove the nut on the front of the differential drive shaft, which I should have loosened by engaging a couple of gears together before I took the top shaft out. It's going to be interesting to see if I can get that undone at this point. And then I can remove the differential drive shaft and check its bearings.